Back with another video. Now this time we already have the sine, cosine and tangent of the half angle. The formulas, the identities are already written and listed here. You can also find them on your formula sheets or in your textbooks, and now we are going to try to do some examples. Probably I'll do one example here and the second example in the next video. Guys, here I want to find or evaluate the tangent of pi over 8, and it says not using like a calculator or just simply by other method. It specifies that I have to use the half angles. Okay guys, if it does not say half angle, then you're free to use a calculator, you're free to use a unit circle, you're free to use any way or any method that you find is convenient and quickest or easiest for you. But here it says half angles, so we got to use the half angle formulas. So to you find the tangent of pi over 8 using the half angles, what we are going to do is we are going to first start, I like to work with the degree measures, then the radians. Guys, it's up to you again. If you like to work with the radians, just work with the radians, that's fine. But I'm going to show you like this one by converting it into degrees. So we can easily do that. So pi over 8, how we convert it into the degrees? We just multiply by a factor 180 over pi, right? So pi's cross out, 180 divided by 8 is 22.5. So basically we are trying to evaluate tangent of 22.5. That's what we are trying to evaluate based on this, using the half angle. So to use the half angle identity, we probably have to use this one. We know that because we are working with the tangent, and then it depends on us whether we want to use this, or this. But first of all, what we want to do is we want to rewrite this as a half angle. So it's not too difficult for us to do that. And we want to usually use the values. Most of these problems you will be able to get values that are like you can identify on the unit circle. So guys, like here we can write this as tangent of 45 divided by 2, because 45 divided by 2 is 22.5. Okay, that is one of the reasons why we chose 45 degrees. The other reason is that 45 angle is visible, it can be identified on the unit circle, so we can use the unit circle to finally simplify and evaluate the tangent of 22.5. Okay, so this is the first thing we want to do, and then from here, guys, let us pick one of the formulas and then go from there. So you can pick whichever you like. I'm not going to pick the radical one. It seems a lot of work. So what I'm going to do is I'm going to pick maybe the third one. Okay guys, try picking second one and see if you get the same thing. You're supposed to get the same value. So let us pick the third one. So third one is sine of theta. But what is theta? Wait a minute. So theta is my 45, right? Guys, I'm just comparing this with this. So there's a 2 here, there's a 2 here, but the angle theta is 45. So it is sine of 45, right? 45 degrees. And then there is 1 plus cosine of theta as well, which is cosine of 45 degrees. Okay, yes, I simply use the third one. I already have these formulas in front of me. I just have to pick one. I use the third one. Here it is. I have theta, but the value for theta here is 45, so I substituted 45 for the theta. Okay, now all I have to do is I have to simplify this right hand side, because we want to find the exact value for this. To simplify this, guys, we need to see the unit circle if we do not remember the values. Okay, if you remember the sine of 45 and cosine of 45, then go ahead and start writing it and simplify. If you do not, then look at the unit circle and then fill those values. So guys, sine of 45 and cosine of 45 actually are equal, are the same. So sine of 45 is radical 2 over 2, and then this cosine of 45 is also radical 2 over 2. Okay, but we cannot leave it like this. We got to simplify. So it's not too difficult to simplify. This becomes radical 2 over 2, and we change this, this equals to radical 2 over 2, which is this piece, and then I'm going to change this division to a multiplication. But when we change it to multiplication, well, before we actually do that, let us simplify this. Guys, to simplify this, and I'm doing it like here on the side, so we got to have a common denominator. So 2 is going to be the common denominator, then I'll have 2 plus radical 2, right? Because there's an invisible 1, so I multiply this by 2, this by 2. So then what am I left with? I have 2 plus radical 2 over 2. But when I convert this big division into a multiplication, it is no more going to be like this. It's going to flip, right? So it's going to be the reciprocal, which is 2 divided by 2 plus radical 2, right? So finally, looking at this, this 2's cross out, I'm left with radical 2 over 2 plus radical 2. Well, we may be tempted to say that this is the final answer, but guys, we know that we don't like to keep radicals in the denominator. But we also know how to get rid of the radicals in the denominator by using the method of rationalizing the denominator. Guys, the rationalizing method is going to show up at so many different places, so it's always good for us to actually practice and know how the rationalizing denominator process works. I have already shown you examples in the past where we had to rationalize. Here again, I'm going to rationalize this denominator. You multiply by 2 minus radical 2 and upstairs by 2 minus radical 2 as well. Not a very complicated process. So from here you can, we can distribute. Yeah, let's distribute. So it's going to be 2 radical 2 minus radical 2 times radical 2 is simply 2. So you can leave it like this here. And then downstairs is a difference of squares, if you can see that. If you cannot, then you have to just distribute or FOIL everything. And finally, you will end up with 2 square, which is 4, minus radical 2 square, which is 2. So finally, you will be left with, let's make room here. So guys, actually here we can see that 2 and 2 is a common factor. So I'm going to take it out. I'm going to be left with radical 2 minus 1. And downstairs 4 minus 2 is 2. Then this 2 and this 2 crosses out. Finally, I'm left with radical 2 minus 1. And I cannot simplify any further than this. Of course, like if you want a decimal value, then you can use a calculator for that. But as far as the radical value goes, this is the best we can do for this. So the exact value for tangent pi over 8 is radical 2 minus 1 using the half angle identity. Okay. So guys, there was some steps here, but we decided to use number 3. You should go ahead and use number 2 and see maybe you can skip some of these steps, or also you can use number 1 and see what happens with that. But I'm sure with number 1 it would be a lot of steps. Okay, but rationalizing is important. One has to rationalize and then get it in the simpler form. Okay. So guys, that is one of the examples on the half angle. I want to show you one more that I will do in the next video, and then we are going to move into verifying identities, which is one of my favorite things. Where we're going to use like almost all of these different identities, maybe 1 or 2 in each problem, or maybe more than 2 in one particular problem, and verify and prove that the left hand side is equal to the right hand side. Okay, guys, till then keep practicing, and I will see you in the next